In this video, we'll create a rotary 4-axis toolpath with Rotary Cut. A rotary toolpath is used on machines that allow simultaneous 4-axis movements to create a 4-axis surface machining toolpath, which cuts around or along the axis of rotation of the machine, in our case the x-axis. The rotary toolpath is a finished toolpath. To demonstrate both rotary cut and axial cut, we are going to finish the part first using the rotary cutting method, and then using the axial cutting method. Select Toolpaths. Choose Multi-Axis. Select OK to accept the default NC name. In the Classic tab, choose Rotary as your toolpath type. Then select the Tool page, and click on Select Library Tool. Select the 1-inch ball end mill from the tool library, and choose the OK button, then enter in the comment. From the menu list, choose Cut Pattern. The cut pattern settings determine the geometry the tool follows and how it travels along the geometry. The rotary cut method is designed to cut around the diameter using 4-axis output. In the surface area here, click on the Select button. Mastercam will prompt you to select the tool pattern surfaces. Select this surface and press the Enter key. Ensure you enable Rotary Cut as your cutting method. Leave the compensation type set to computer with the direction left and tip compensation set to tip. Change the stock to leave on drive surfaces to 0.005. Leave the cut tolerance set to 0.001. Change the direction of open contours to one-way. Select Tool Axis Control. Leave the rotary axis set to the x-axis. The tool axis control settings determine the tool's orientation in relation to the geometry being cut. Use Center Point allows you to generate tool vectors that terminate at the selected point. Deselect it to generate vectors that are normal to the surface. Axial dampening length determines the angular change between the vectors. A longer axis dampening length creates less angular change between the vectors. A shorter length provides more tool positions and a tool path that adheres closely to the surface. Lead lag angle, positive or a negative value, tilts the tool forward or backward in the direction of the toolpath. Change this to positive 10 degrees. Maximum step controls the distance between passes. The distance is measured parallel to the axis of rotation. Tool vector length controls the toolpath display by determining the length of the tool axis at each tool position. The recommended value is 1 inch. Select Linking. Enable clearance with a value of 6 inches. Disable Retract. Change the feed plane to 1.5. Select the OK button to generate this toolpath. Once the toolpath is finished generating, choose Backplot. As you watch your backplot, stop it at any point. Right-click on the screen here and choose the right side view, and notice that the tool is tilted. This is a 10-degree angle. Once the backplot has been completed, close the Mastercam simulator. Then we will copy this toolpath over to the left-hand side. Right-click on this toolpath and choose Copy. Right-click down in this area and choose Paste. Select the parameters of this toolpath. In the cut pattern area, click on Select beside surfaces. Unselect this surface and choose this surface here and press the Enter key. Select the OK button and regenerate this toolpath by selecting Regenerate All Dirty Operations. Once the toolpath is finished generating, you can then verify both toolpaths. Select all of the operations and verify them. Once the simulation has finished, close the Mastercam simulator, then toggle the toolpath display.